Good afternoon. This is section 2 of chapter 6, day 2 that is, and we're going to be using what we call related functions to solve. So, first way we're going to use related functions is we're going to take a quadratic that is in one dimension, which means only x, and we're going to convert it to a two-dimensional equation that has a y in it and use that to solve. So remember that we have the standard form of a parabola, which is y equals ax squared plus bx plus c. So to solve this graphically, we're going to take this and we're going to turn it into the related function, which is a two-dimensional function that has x and y both. So to prepare this, to change it to that, we need it to be equal to 0. So we're going to add 5 to both sides. So we've got x squared minus 6x plus 5 equals 0. Okay, so we need to figure out what's going to make that equal to 0. So what we're going to do is set y equal to 0 and make our new function. So when we do that, 0 is now y equals x squared minus 6x plus 5. So because y is equal to 0, my solutions in two dimension are going to have a 0 for y. In other words, my solutions are x-intercepts of the graph. That's why this is called solving by a related function. The original one was only in one dimension. It only has x. We're going to convert it to a two-dimensional equation. We're going to graph it. And because originally y was equal to 0, wherever that graph crosses the x-axis is a solution of the original. Okay, so let's work with what we've got here. This is a quadratic in standard form. So we need a vertex, and remember the formula for vertex, -1 times b over 2 times a. So -1 times -6 over 2 times 1, because of course a is that invisible 1. That gives us 6 over 2, which is 3. Now to get the y-coordinate, so that was the x-coordinate for the vertex. For the y-coordinate, you take the 3 and substitute it in. So y equals 3 squared minus 6 times 3 plus 5. So we do the, we do the perfect square first. Minus 18 plus 5, so -9 plus 5 is -4. So our vertex is 3, -4. Now we're instructed to solve this graphically, so we're going to start making our graph. So draw yourself a good pair of axes. Remember, it needs to be bigger than a Post-it. Put your vertex in. 1, 2, 3 to the right, and 1, 2, 3, 4 down. Now our a value in this is a +1, so this is going to open upward. The a value is also equal to 1, so this is a medium bell. As a result, we have 2 points we get for bonus. So again, just to put that out here on the side, a is positive, so it opens up. And the absolute value of a is 1, so it has a medium bell, and we get these 2 bonus points here. So this one is 2, -3. This one is 4, -3. So this is where you're going to need to guess a little bit where it's going to cross. I'm guessing that it's going to cross here and here. So I'm going to go and do a little t-chart here on the left-hand side. Actually, I'm not going to do a t-chart. I'm just going to sub the values in. So if x is 1, then y is 1 squared minus 6 times 1 plus 5. Exponent first. Now multiply 1 minus 6 plus 5. Well, -5 plus 5 is 0. So I just found an intercept at 1, 0. Now we know it's symmetrical, so if 1, 0 is an intercept, then 5, 0 has to be the other one. All right, let me draw the graph in. Now the purpose of this graph was to solve for x. Remember that in the beginning we replaced 0 with the y. So wherever y equals 0, we get our solutions. Well, these are the two places where y equals 0, 5, 0, and 1, 0. So what have we got? Okay, we're going to label this really clearly. Our x-intercepts off of our graph are 1, 0, and 5, 0. Now the original graph was only in one dimension. So the solution to our original equation is x is positive 1 and 5. So again, the x-intercepts come off of the graph. This is, by the way, the related function, the one that is two-dimensional. We use it temporarily to get the intercepts, and then we take the y back out again, so x has to be 1 and 5. All right, so that is our first example. Solve graphically by finding x-intercepts. You replace, or first algebraically solve equal to 0, set y equal to 0, and make a new two-dimensional function. Graph that function just like we would normally. And because we set y equal to 0, anywhere y equals 0 will give us our solution, which it did. It was x equals 1 and 5. That is solving by graphing the related function. If you give this answer, it will be incorrect because x-intercepts were the related function. It wasn't the original. The original equation only had x's, so your answer should only have x's. All right, Roman numeral 2. Little review topic. We're going to solve by extracting square roots. Solve by extracting square roots. This is a quicker way to solve than completing the square or quadratic, so it's nice when it works out. All right, let's do an example. We have 2x minus 1 squared minus 9 equals 0. Okay, how do you know when to solve by extracting square roots? Okay, when you solve by extracting square roots, you need a perfect square, which we have here, 2x minus 1 squared. That's your perfect square. And all x's are inside that perfect square. So we only have x's here, we have none over here. If that is the case, then you can solve by extracting square roots. So you got to check those two things. All right, so what are our steps? Number 1, you're going to isolate the perfect square. So on this equation, we're going to add 9 to get it over to the other side. Now I've got 2x minus 1 squared equals 9. That's your first step. Step number 2, we say extract square roots, which basically means you take a square root of both sides. Square root of the entire left, square root of the entire right. Okay, third step in the process, you're going to split the perfect square and solve for 2 answers. All right, so this is where we're going to split. So I have a positive 2x minus 1 equals, and of course the square root of 9 is 3, so we'll just go ahead and do that. And then a negative 2x minus 1 equals 3. And we should get an answer out of both of those. When you distribute a positive, nothing changes. So we're going to add 1 over there. We get 2x equals 4. So x equals 2 is one of our answers. On the right, distribute the negative. You get negative 2x plus 1 equals 3. subtract the 1 over to the right-hand side, so negative 2x equals 2. So x must be negative 1. So for both of our answers, x is an element of the set containing 2 and negative 1. That is solving by extracting square roots, which we have practiced, but it's been a little while. All right, the last one we're going to review on the notes today, Roman numeral 3, is solve using the quadratic formula. Okay, so just to review, when you solve using a quadratic formula, you have to have your equation in the form ax squared plus bx plus c equals 0. The a term can't be 0 or it would not be a quadratic and this won't work. Your formula is x equals negative 1 times b plus and minus the square root of b squared minus 4ac all over 2 times a. All right, the equation we're going to solve is 2x plus 1 times x minus 2 equals 0. Now on your homework, they're going to give you all kinds of weird looking equations. If your equation has fractions, you can clear the fractions and then get a new a, b, and c. Sometimes that's easier than doing the fractions in the formula. This one, though, we need to multiply out. So when we do, we get 2x squared minus 3x minus 2 equals 0. So a is 2, b is negative 3, c is negative 2. So now we're going to place a, b, and c into the formula. So negative 1 times b, which is negative 3, plus and minus the square root of b squared, so negative 3 squared, minus 4 times a, which is 2, times c, which is negative 2, all over 2 times a, which is 2. The biggest challenge with using quadratic formula is just simplifying it without making a mistake. You can simplify the top and the bottom, the front and the bottom in the beginning. So you have a positive 3 and a 4 on the bottom. This inside, though, takes a couple steps. Typically, follow your order of operations. Do exponents first, so negative 3 times negative 3 is positive 9. And then you're going to multiply from left to right. Now here's a great trick. Instead of thinking of it as subtracting by 4, think of it as a negative 4 being multiplied by those two numbers. Negative 4 times 2 is negative 8. Negative 8 times negative 2 is positive 16. See how much easier it is to figure out what sign is on the 16? This is probably the number one thing that messes people up, is when they have this negative and a number. So that's a nice trick to use. I'll put it here on the side. Negative 4 times 2 times negative 2. If you treat it that way, you will be less likely to make a goofy mistake. Well, 9 plus 16 is 25. And here's where we're going to need to split our answers, because we have a plus and a minus. We have 3 plus, let's see, square root of 25 is 5, all over 4, and 3 minus 5 over 4. 5 plus 3 is 8. 8 divided by 4 is 2. So one of our solutions is 2. 3 minus 5 is negative 2 over 4 is a negative 1/2. And there is your answer. Remember the element notation. The last thing I want to throw in, I mentioned it in passing, but I think I'm just going to start an example. Let's say that you're given an equation with just some really ugly numbers, like 1/2 x squared plus 3x minus 1/3 equals 0. That thing is going to be wicked awful to put into the quadratic formula. So what we're going to do is clear the fractions before we put it in the formula. The numbers will get bigger, but at least it will be more manageable. So 2 and 3, 6 is the lowest common denominator, so we're going to multiply this by 3 over 3. the middle one by 6 over 6, and the right one by 2 over 2. That gives you 3x squared over 6 plus 18x over 6 minus 2 over 6 equals 0. Now that you have a common denominator, clear it by multiplying both sides of the equation by 6 over 1. And of course, as you distribute the 6, it cancels out all the bottoms. Over here, 0 times anything is 0. So now you've got 3x squared plus 18x minus 2 equals 0. And then from there, you could do the quadratic formula, and you've got whole numbers to work with instead of big, nasty fractions. Anyway, I just wanted to show you that trick to make your life a little easier. Have a good afternoon.